In this video, I'm going to show you how to build a complete blockchain application step by step, a DeFi app. We're going to build a digital bank where you can earn interest for depositing cryptocurrency, just like some of the hottest apps in the DeFi space right now. I'll guide you through the entire process, building the app from start to finish. We'll set up a blockchain, create Ethereum smart contracts, write tests for them, and also create a client-side website so that people can actually use the application. And you might be thinking like, hey, slow down. I don't even really know what a blockchain is or how it works. That's okay. I can show you everything before we start coding. And I'll also show you all the programming languages that you need to know along the way. You don't have to be a developer in order to watch this video. So really quickly, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash the like button down below for the YouTube algorithm and subscribe to this channel. And if you like this video and you want to take the next step and you want to learn how to master blockchain from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so before we start building the project, let me go over what a blockchain is and how it works. But if you understand these things already, then feel free to skip ahead. There should be a link to a table of contents down in the description below. So what is a blockchain? Well, to answer this question, let's look at how a web application works. Normally, when you use a web app, you use a browser, and that connects to a central server. This server hosts all the code for the web application, and all the data is stored inside of a central database. This presents a big problem. This is a great model for a lot of things, but it has some limitations. You can't store value this way. For example, you can't create a digital money with a traditional web application. Why is that? See, the code can be changed by the developers at any time, and the data can be changed arbitrarily at any time by anyone who had access to the database. This means that whoever controls the money could manipulate your balance and steal your funds. So we don't want to build a centralized web application to handle money. Instead, we want to use the blockchain. This will guarantee that no one can change the code of our application or manipulate the database. We can rest assured that our money will always work in a predictable way and that our funds won't be stolen. How can you achieve this with blockchain, you might ask? Well, let's take a look at how a blockchain works. A blockchain is basically just a giant worldwide computer. Instead of a single computer that stores data and runs programs, blockchains use thousands of computers to handle this. Each computer is called a node, and all of the nodes talk to one another. Each node gets a copy of all the code and all the data that's stored on the blockchain. All of the data is stored in bundles of records called blocks, which are chained together to make up the public ledger. All the code is stored in smart contracts, which are immutable programs that run on the blockchain. This creates an endless possibility for a new generation of applications that are not controlled by anyone, but instead run by themselves on the blockchain. The cryptocurrency is a great example. You can create a cryptocurrency with a blockchain because each node is responsible for processing transactions and tracking your balance. Whenever you send cryptocurrency, the network achieves consensus that your transaction is valid and that your balance is properly updated on the ledger. Now let's look at how a blockchain application, or a Dapp, works. For this tutorial, we're going to use Ethereum. To access this application, you use your browser and you connect to a front-end application that's written in HTML, CSS, and JavaScript. Then, instead of accessing a back-end server, the website talks directly to the blockchain. This is where all the code and the data for the application is going to live. This code is contained in smart contracts written in the Solidity programming language, which looks a lot like JavaScript. These smart contracts are immutable, which means the code cannot change. And all the data is stored on the public ledger, which is also immutable. And anytime we add new data to the blockchain, it will be permanent and publicly verifiable. So that's an overview of what a blockchain is and how it works. Now let's get a preview of the app that we're going to build together and how it leverages the power of the blockchain. Here's a preview of the application that we're going to build together in this tutorial. This is a DeFi application that works a lot like a bank, where basically you deposit your cryptocurrency into the application, and while it's deposited into the application, you actually earn interest. So this is called staking, where you take a cryptocurrency, you deposit it into the application, and then you earn a different cryptocurrency over time. It's a lot like depositing money into a bank account. So in this case, we're going to work with a real-world cryptocurrency, the DAI stablecoin. This is a stable cryptocurrency pegged to the US dollar so the price doesn't change. And we'll let users deposit DAI into our application, and they'll earn a brand new token called Dapp token that we'll create in this tutorial. So one of the reasons I've chosen this application is because it's part of a really hot trend in DeFi right now called yield farming or liquidity mining. So hence the name Dapp token farm. This is basically where applications incentivize users, to use their application by issuing them a token. And in the background, these applications use the deposited funds to issue loans and things like that, just like a bank. So this is a really common trend right now, and it's a brand new way of issuing tokens. It's a lot like the big ICO trend that happened in 2016, 2017. But the big difference here is that you don't have to buy the cryptocurrency. All you have to do is deposit some cryptocurrency into the app, and then you earn the new cryptocurrency as a reward for doing that. So let's look at a diagram of how this application is going to work. We're going to create a website in HTML and CSS and JavaScript, also using React.js. And that website's going to talk directly to the blockchain. And we're going to create a smart contract that handles the back end. This smart contract will allow us to stake tokens to the application and also reward users with new tokens as interest for using the app. We'll write this smart contract with the Solidity programming language, and we'll deploy it to a development blockchain that we'll install on our computer. Now let's install all the dependencies that we need to build our project. The first dependency is Node.js. You can see if you have Node already installed by going to your terminal and typing node-v. If you don't have Node already installed, you can download it with a command line tool like Homebrew, or you can just go to the Node.js website and install it directly. I'm using Node version 12.18.3, and I suggest you do the same thing for the best results in this tutorial. The next dependency is Ganache, which is a one-click blockchain. This will allow us to spin up a blockchain on our computer so that we can write smart contracts and, put them on the network. I'll put a link to this page down in the description below, but basically you can just automatically select the version of Ganache that you need for your operating system and run a one-click installer. And whenever you open Ganache, you see a window like this. This means that Ganache is running, and you can see that you have 10 accounts automatically populated here, and each of these accounts has 100 Ether, the native cryptocurrency of the Ethereum blockchain, credited to their account, okay? So you can see your account address, which is a lot like your username, and you can also see the private key, which is a lot like the password, by clicking this key right here, okay? And so finally, I'll say, don't ever use this account in the real world, because anybody who's watched this video has seen this private key and could steal your funds. The next dependency is the Truffle framework. This is a suite of tools that will allow us to write Ethereum smart contracts with the Solidity programming language. We'll be able to create projects on our computer where we can write the code for the smart contracts, we can write tests against them, and we can also deploy them to the network. I'm going to use a very specific version of Truffle in this tutorial, and I suggest that you do the same. So you can go to your terminal and type in npm install --g space truffle at version 5.1.39. The next dependency is the MetaMask extension for Google Chrome. MetaMask is an Ethereum wallet that turns your regular web browser into a blockchain browser. And you'll need to install it in order to build the tutorial in this video. So head on over to the Google Chrome web store, search for MetaMask, and install it. Once you've done that, go to your Google Chrome extensions and ensure that MetaMask is enabled. And you can confirm that it's enabled by looking at the little fox icon in your top right-hand corner. All right, now let's get started coding. So instead of creating all the files from scratch, we're going to start with a template. So I've saved the starter code for this particular tutorial on GitHub, and I'll show you how to download it. So we're going to use this link right here, the GitHub URL, but I'm going to show you how to clone the specific branch that we need to start off with, okay? So if you're new to Git, don't worry. You don't have to understand everything that's happening here. You just need to copy and paste this command verbatim in your terminal. I'll put a link to it down in the description below. This is git clone, and we tell it the branch name that we want to clone, and that's that -b is here, so starter code. And then we put in the URL from GitHub here. All right, and then we tell it the name of the new project that we want to create, which is DeFi_tutorial, okay? So do it like that. And you'll see this kind of scary output here, but that's okay. I'll show you how to fix that. Say cd DeFi tutorial. All right. And now what I'm going to do is say git checkout -b master. Okay. So this will create a brand new project for you. And just as a quick sanity check, I'm going to open it in my terminal just to see that all the files are downloaded properly. Or we can just do it like this, say ls-l. All right. That shows the files, and we can open it in the terminal like this, subl dot. Okay, so sometimes people ask me, what does that mean? Well, I have this special command on my computer. It's called a symlink to open Sublime Text. That's my text editor. So that's what subl means. And then dot opens it in the current directory, okay? So you don't have to do that. You could just open it manually with Sublime Text just by navigating to the app and, opening the folder. That'd be fine too. So yeah, it downloaded just fine. I can see all the files here. So we'll come back to that tour in a second. But what we really want to do is install all our node dependencies. So we can say npm install, all right? And whenever that's done, you should see an output that looks like this. So you'll definitely see like a lot of warnings. Okay, they're just warnings. As long as your packages install correctly, it'll work for the tutorial. Granted, it's not ideal, but that's just sort of the state of things right now with this current technology. So the next thing you want to do is open Ganache. All right. And you want to make sure that you have a blockchain running before you do anything else. All right. So that's what Ganache is. So this is a point-and-click development blockchain. Again, you can see that it has given us 10 accounts for free, okay? These are all the addresses of the accounts on the network. So your address is sort of like your username. It's a representation of your public key. And you can also see the private key here by clicking the key icon, all right? So again, you definitely don't want to show this to anybody or use this to store real money on the actual Ethereum network because, you know, anybody who's seen that private key could steal your money, okay? So all these have 100 fake Ether in them. Then you know the native cryptocurrency of the Ethereum blockchain. This isn't worth anything on the real blockchain, so don't get too excited. That's a quick overview of Ganache, and we'll just let this run in the background, but you need to make sure you have it started right now before we continue on with the tutorial. All right, so let's look at the project code that we downloaded. So a few key files to look at. The first is the package.json file. Okay, so this is the file that keeps all the dependencies for the project. So you can see like Web3 is inside of here. That's Web3.js that we use to connect our application to the blockchain. It's got the Truffle dependency. It's got the React dependencies. We're going to use React to build the client-side application in here. Bootstrap, and a bunch of other dependencies that we need to make our project compatible with ES6. That's the more updated version of JavaScript, okay? So next is the Truffle configuration file, okay? So this is how we actually connect our Truffle project to the blockchain. In this case, we connect to Ganache, okay? So if you'll notice, Ganache is running on port 7545 localhost, and that's what this line here does. Basically, it says, here's your development network or your development blockchain. It runs on localhost, which is the same thing as 127.0.0.1. That's just the localhost IP address. And then the port is 7545, which matches Ganache right here, all right? The next thing that you want to notice is that I've added some additional configuration here. So if you've used a Truffle project before, this might look a little different. I've changed where the smart contracts go in this tutorial because I want them to be exposed to the client-side application that we're going to build later. So what do I mean by that? Well, normally when your Truffle project, your contracts are in this contracts directory at the top level, I think, but they're inside the source directory for this project. So source contracts, you should already see some contracts inside of here. And whenever we compile the smart contracts, they'll also go inside the source directory as well. That's because we're going to create a React application inside of here, inside this components directory. You can already see this app.js file. We'll come back to this later. But basically, we need this file to understand where the smart contracts are, et cetera, et cetera. So that's why inside the truffle-config file, we put them in the source directory. All right. So don't worry if that doesn't make any sense just yet. But I wanted to call that out before we continue on. But yeah, let's not belabor the setup. We'll continue on with the tour here. Of course, the node modules are where all the libraries go, the migrations. We'll come back to that in a minute. Let's go ahead and look at the code. So let's start with contracts, okay? So we're going to write a few different smart contracts in this tutorial, okay? I'm going to go over what they are. Two of them are actually going to be done for you already, okay? They're actually in the project already. So these are two different cryptocurrencies. The first one is the DAI token, all right? And the second one is the Dapp token. So what do I mean by that? Well, DAI is a stable cryptocurrency whose price doesn't change. It's pegged to the US dollar. It runs on top of Ethereum. And it's very useful in the blockchain space, DeFi space, because the price doesn't change. And people like to hold DAI because, it has a predictable price. It has a lot of use. And DAI is actually powered by a smart contract. It's an ERC20 token, which basically just means that it's compliant with the ERC20 standard, okay? It has a predictable set of functions like the name, symbol, decimals, total supply, transfer, et cetera, okay? Basically, that just means that it's compatible with lots of different Ethereum wallets, exchanges, and things like that, okay? So, we're going to use the DAI token in this, or at least a mock DAI. So I'll just put a note here, mock DAI. we're basically going to have a pretend version of DAI that's already inside of our project, okay? So it's a done for you token that's already inside of there. We'll simply deploy it to the network. It'll act like DAI. It'll stand in place of DAI, and we'll just treat it like DAI in this tutorial, okay? It's a lot easier than trying to actually use the real DAI token. And it'll show you how to deploy tokens yourself, okay? So the second one's going to be Dapp token, all right? This is a fictitious cryptocurrency. Doesn't actually exist. We're just going to kind of make it up for this tutorial. And it's also going to be an ERC20 token as well, okay? So the whole idea is that when we create our digital bank, people will hold DAI tokens or the mock DAI token, and they'll deposit it into the bank, okay? And they'll earn the DAI tokens, the Dapp tokens as interest. So they deposit one token and they get a brand new token, but they're able to, withdraw their mock DAI tokens later and have both essentially, okay? So that's contract number one, is an ERC20 contract for mock DAI. The contract number two is the ERC20 token for Dapp token. And so those are actually already in the project. So there's a few reasons for doing this. I didn't want to spend a bunch of time in the tutorial just creating ERC20 tokens. If you want to learn how to create an ERC20 token step by step, I have an older tutorial on this channel, how to code your own cryptocurrency on Ethereum. You can see that step by step. Also, if you want to learn step by step, write tests against them, you can certainly do that inside the blockchain bootcamp as well. But, ERC20 tokens, the code for these tokens are both basically the same. All right. It's just that the name has changed. So mock DAI here, and then the symbol, and for Dapp token, just Dapp token and Dapp. Okay. So I didn't want to spend a lot of time on those in this tutorial. What I really want to spend time on is creating this smart contract right here, okay, the token farm, because this is going to have a lot of custom behavior, all right, that we actually need to learn how to build to create this unique project. A lot of ERC20 tokens work very similar to one another, so it's kind of a solved problem in a sense. And I don't spend a lot of time on that. I'd rather spend time on learning Solidity so that you can create this right here. So this token farm is where we're going to do yield farming. That's where we're going to let users earn interest and earn these new tokens. And this is what's going to act like our digital bank. Okay, so this is what we're going to spend most time on. We're going to create this from scratch, code out all the functions step by step, write tests against it, deploy it to the blockchain, all that kind of stuff. So with that being said, let's go ahead and jump into the project and create that new contract like this. So we'll go into this contracts directory and create a new file. All right, I'm going to call this token farm. All right, .sol. So it's a capital T for token, capital F for farm, .sol. All right, and .sol is the file extension for Solidity. All right. And so I'm going to bump up the font a little bit here. And the first thing we want to do is declare the Solidity programming language like this. So we say pragma, Solidity. We use a caret, 0.5.0. Okay. And then next we say contract, token farm. All right. Then we use some curly braces like this. And there we go. That's the basic skeleton for our smart contract. So we just say contract, we give it a name, token farm, and then we're going to write all the code for it inside of here. So all code goes here. And then this is ending curly braces where the contract finishes, and then I give it an empty line at the end of the file like that. Okay. So the first thing we want to do is just give the contract a name so that we can deploy it to the blockchain really quickly and just make sure that everything is set up properly. We'll do a smoke test, okay? So we'll say string public name equals Dapp token farm. And then after the quotation, we'll do a semicolon, okay? So boom, we'll just save it like that. So what I've done here is created a variable inside the smart contract. It's called a state variable. So what that means is this variable value is actually going to get stored on the blockchain, okay? So we call it string because Solidity is a statically typed language, which means that we basically have to tell it what kind of data is going to live inside this variable. So in this case, it's a string, and we can't, reassign this to any other type. It can't be, like a number or anything like that. It always has to be a string. So we say name is going to be a string, and we call it Dapp token farm, okay? And then we also give it this public modifier or visibility here, which basically means that we'll be able to access this variable value from outside the smart contract, okay? So I'll show you that in action. What we'll do is we'll compile this smart contract and deploy it to the blockchain, and then we'll try to fetch this variable value out of the console so that you can see what it takes to do those steps and actually fetch this value back. And that'll show us that the project's been set up properly. We can connect it to the blockchain. We can create our first smart contract, all that kind of stuff, okay? The next thing we want to do is go to this migrations file and see this initial migrations file here, all right? And I'm going to copy this. And I'm going to say create a new file inside the same directory. So you'll see this says 1_initial migrations. Well, we want to create a new file that says 2_deploy_contracts.js, okay? So what this migration file is going to do is put new smart contracts on the blockchain. So that's what a migration is. It migrates them from one place to another. That's one way you can think about it. The other way of thinking about it is that the blockchain state actually changes whenever you put new smart contracts on it because you're creating transactions. And so you're migrating the state of the blockchain from one state to another. So either way works. So I'll just paste it inside of here. And I'll modify this, okay? So what we want to do is put our Dapp token farm smart contract on there, okay? So instead of migrations, I'm just literally going to copy, just replace this and say token farm, okay? And then I'll modify this to have single quotes. I just like to do that and then take off the semicolons. All right. So now we save that, and we have a migration file to put new smart contracts in the blockchain. And also, if you've come from a different development background, you might have done like migrations for a database. This is the same kind of thing because the blockchain fundamentally is a database, and we're migrating it whenever we put new smart contracts on the blockchain. All right. So next, what we want to do is deploy them. So we can say Truffle compile, just to make sure that the code compiles properly first. All right, boom, there we go. So whenever that happened, you can see that the new contracts were placed inside of here, ABIs, okay? So we can see the token farm JSON, all right? Then also for the Dapp token and the DAI token, because those smart contracts were already inside of here. Okay, so just as a note, we're not putting the tokens on the blockchain yet. We're just putting the token farm smart contract, okay? But, inside this ABIs directory, what this has done is it has created some JSON files that store a description of how the smart contract works. That's what this ABI is here. So also, this ABIs directory is not necessarily the best name for this because technically the ABI is contained inside this file. Okay, this is like the Truffle artifacts. But basically, all you need to know is that this JSON file just describes how the smart contract works. Okay, and this also contains its address whenever we deploy it. So let's do this. We'll say Truffle migrate. All right, this is the command used to actually put the smart contracts on the blockchain and run the migrations. And whenever that is working, okay, boom, we should see that our Ether balance went down inside of Ganache. Okay, so that's really important to know. So really quickly, I'll explain that. So basically, whenever you put smart contracts on the blockchain, you're creating a transaction, you're writing data to the blockchain, and anytime you have to do that, you have to pay a gas fee, okay? And that gas fee is expressed in Ether, okay? So the first account is the default account for Truffle. So basically, we're assuming that the first account in this list is the person who's deploying the smart contract whenever we run the migration, all right? And that account had to pay a little bit to put the new smart contract on the network, and that's why the account balance went down to 99.99 instead of 100 right here, okay? So now we can open the Truffle console to actually interact with the smart contract on the blockchain. So we'll do that like this. We'll say Truffle console, okay? And inside of here, I'll interact with the smart contract like this. I'll say token farm equals await, capital T, token, capital F, farm, dot deployed. All right, so you'll see undefined here, and this confuses a lot of people. It probably confused me the first time I saw this. So it actually worked, but in order to see the smart contract, you have to call the variable values. I say token farm, and then boom, there we go. We can see the actual value returned here. So I'll explain this. What we've done is fetched the smart contract for the blockchain. Actually, let me back up even further. So what did I do whenever I open the Truffle console? Well, the Truffle console is a JavaScript runtime environment that lets you use the blockchain. And so in this case, we're connected to our Ganache development blockchain. And now we have access to any of the transactions that were created on that blockchain, any of the smart contracts that were deployed. And so now what we're doing is in JavaScript, so not in Solidity. We wrote this in Solidity, but now we're in the Truffle console, we're writing JavaScript. And what we did was we fetched the token farm contract from the network by saying token farm.deployed, and we stored it to a variable called token farm. And so we defined token farm in JavaScript when we create this migration like this. That's why we use capital T, capital F, token farm, okay? And then we said token farm.deployed here. So this is a function. And we use this await keyword because whenever we interact with the blockchain, it is asynchronous in nature because it's slow, okay? And so this deployed function, what it does, it's an asynchronous function call, and it returns a promise. So this gets really confusing if you've never coded before. I highly recommend looking up how promises work in JavaScript and how the async await pattern works. It was really confusing to me the first time that I encountered this. So you want to read more about that if you're confused, but the simple explanation is this returns a promise. It doesn't actually return the token. So if I just said token farm equals token farm.deployed, that wouldn't necessarily work. All right. So if I use the await keyword, then it returns a promise. It waits for the function call to finish, okay, to actually resolve, and then it assigns it to a variable. So basically just know that this won't necessarily work and this will if you want the really simple explanation. But if you want the more advanced explanation, I would look up how promises work and then how async await works, okay? Okay, so next we want to do is just inspect the address. So we can say token farm dot underscore address, okay? Actually, let's see here. Yeah, there we go. Sorry. So don't do the underscore address. This is a change in Web3 that looks like it hasn't made it into this version yet. So don't listen to that. You need to do it this way. Token farm.address. And here's the address of the network. So boom, there we go. Awesome. So this is the address of the contract on the network. So again, users have addresses just like this, like your username, but smart contracts also have addresses that tell you just where it lives on the network. Okay, so we can also check the name like this. You say name equals await token farm dot name, and then call it like a function like this. All right, then name, boom, Dapp token farm. All right, so that's a good setup for this first section. I think we covered a lot of ground. So in the next section, what we'll do is actually start building out this project and start, depositing tokens and actually building out this token farm to act like a digital bank that does, yield farming and interest bearing. All right, so now let's continue building out the token farm smart contract, okay? So let me kind of illustrate what we want to try to accomplish here, okay? So again, we have 3 smart contracts in the project. We have the DAI token smart contract. This is the fake DAI or mock DAI, the Dapp token smart contract, and then the token farm, okay? So you can see this here. Here's the DAI token. Oh, not this one. Sorry. The DAI token right here. Again, this is just a fake DAI. That's ERC20 token. It's a smart contract. The Dapp token, which is the fictional token that we earn in this tutorial, and then also the token farm, okay? So let me just kind of explain how this works again. Basically, we're assuming that an investor, the person that uses the token farm, the digital bank, essentially they hold, mock DAI, and they put it into the token farm smart contract. They stake it, okay? And then whenever they stake it on some sort of regular interval, they earn the Dapp tokens for doing that, okay? And then they can withdraw the Dapp tokens, and they get the Dapp tokens directly to their wallet, but then they can withdraw their initial DAI tokens for doing that, okay? So what we need to do is basically allow this smart contract to take DAI deposits and then issue Dapp tokens. We're not going to accomplish all of that in this section. That's actually going to be the final part of this. But what we need to do in the very least is make this smart contract aware of the DAI token and also the Dapp token. So in order to do that, we need to import them into this file. So the other contracts are already right here. So we can say like this, boom, import, and then space, quotation marks, the ./Dapp token.sol, okay? And then the same thing for the DAI token like this, boom, okay? So now that's pulled those smart contracts, at least the source code, into this particular file, okay? And so now what we do is we want to make the token farm smart contract aware of those whenever it's deployed to the network. So we're going to create something called the constructor function like this, a constructor. All right, so this is a special function that gets run once and only once whenever the smart contract is deployed to the network. All right, so this is a function, which basically means we can put code inside of here. And whenever this function is called, it will just execute all the code, within these curly braces, okay? So what we want to do is actually store a reference to the Dapp token that's been deployed to the network and also the DAI token that's been deployed to the network. So we can create variables inside of our project to do that. So basically we need the address of the tokens on the network whenever they're deployed and put in this project, okay? So I'll show you how that works. Basically, the deployment process will look like this. It'll look like, step 1, deploy DAI. Step 2, deploy Dapp token. Okay, step 3, deploy yield farm or, token farm. Okay. So basically, we're going to assume the Dapp token's already been deployed to the network. The DAI token's already been deployed to the network. So all we need to do is grab the address from these steps right here. Okay, and then pass them into the token farm contract whenever it's created. Okay, so we do that like this. We say Dapp token, and then DAI token. All right. So basically, what this is these are function arguments. All right. And these are the variable names, so Dapp token and then DAI token, and these are the type. All right, so the type is actually the smart contract itself. So Dapp token's a smart contract. That's the contract type here. We pass in the Dapp token address and then the DAI token address. Okay, and then what we'll do right here is say Dapp token equals Dapp token, and then DAI token equals, token equals DAI token. All right. So what we'll do is assign these to state variables right here. So we'll say Dapp token public Dapp token, and then also DAI token public DAI token. All right. So this might look a little bit confusing, but I'll explain one more time. Oh, then last thing, sorry, we need to say public right here because this needs to have public visibility in order to run. So again, this might be a little confusing. This may not be the best thing to try to do if this is the first smart contract you've ever written, but I'll explain what it is. It might be a little advanced. Essentially, we've created 2 smart contracts already, the DAI token and the Dapp token, or we will eventually. And then once those are deployed, we take those addresses and we pass them into this smart contract whenever it's created. So the Dapp token address, the DAI token address, and then we take those variables and we assign them to state variables right here because, these variables are just local variables. They're not accessible to other functions that we'll create later, like down here, okay? So in order to access those and other functions and outside of the smart contracts, we have to save them as state variables, okay? And then, of course, All the variables in Solidity have to have a type, okay? So that's what this is. So Dapp token is actually a smart contract, is the type, and then the DAI token is also a smart contract, it's the type. So you see that type here whenever you pass Dapp token address in, DAI token, whenever you pass a DAI token address in, and then we save those as smart contract types, essentially, as state variables here, okay? So it'll all make sense as we start coding out the other functions. This is kind of just a weird setup step that we have to do right now that probably won't make a ton of sense until you really see it in action. So if this doesn't make sense, don't worry, it'll make sense later. All right, so the next thing we need to do is modify this migration file here. So this deploy contract step, we actually want to put the DAI token and Dapp token smart contracts on the network, okay? We will do that like this. First and foremost, we will import the new tokens. So just above this, we'll put these lines in here. So const Dapp token, and then, you know, that, DAI token, and then that. So it's the same thing as this line right here, just change the names to match the new smart contracts, okay? So I'm gonna modify this function quite a bit. So I'm gonna add the async keyword here, because we want to do some step-by-step procedures inside this migration. All right. And so we also want to add some more variables because we want to know the accounts that are on the network. So the variables that are accessible inside this migration file are the deployer, which puts the smart contract, puts the smart contracts on the network itself, and then the accounts. Okay. So this is actually all the accounts from Ganache right here. So we have access to an array of accounts like this. And that's important because we're going to give an investor some tokens so that they can use the project, okay? First, what we're going to do is deploy the mock DAI token. So we'll do that like this. We'll say, boom, await deployer DAI token, okay? And then what we'll do is once that's finished, that's why we use the async and the await keyword here. Once that's finished, we'll actually fetch the DAI token from the network because we need to get the address, because remember, we're going to put the address back in here whenever we create the token farm, all right? So that's the first step. The next step is to do the same thing for the Dapp token, okay? So boom, all right? So deploy Dapp token, and then fetch it back and assign it to a variable. And then we want to actually update this to pass in the function arguments whenever we deploy the Dapp token farm, okay? So we'll replace that line with this, all right? So await deploy token farm, and then we pass in the Dapp token address, all right? That's, you know, here, Dapp token address, and then DAI token address, okay? Just like we do here. So that's always a Dapp token and then DAI token, all right, boom. And then lastly, inside this file, well, first of all, that puts all the smart contracts on the network. So we could stop there and boom, it will be done. But I really want to do two more steps inside of here, okay? All the smart contracts are on the blockchain, but first, I want to assign all the Dapp tokens to the token farm smart contract, okay? So what do I mean by that? Well, basically, you know, we got this sort of diagram here. I'll just draw this out in a more, like, a better way. So we got DAI token, we got the token farm, and then we got the Dapp token. So, you know, from an investor's perspective, right, the investor is going to put DAI tokens in the token farm, and then it's going to earn Dapp tokens back. So what we want to do is assign all the Dapp tokens to the token farm. That's how these other projects work in the real world. Essentially, they put all the tokens in a liquidity pool, and then the app can distribute those tokens. So basically, like, we want to put all of the Dapp tokens inside this token farm project so that when investors use the app, that's how it actually distributes the tokens. So it's like an ICO kind of, but instead of buying the tokens, they earn them through liquidity mining or yield farming. Like, they basically deposit their DAI tokens into our bank, our digital bank, and then we pay them interest with a new token, you know, this Dapp token, for using the project, okay? The first thing we can do is basically just transfer some tokens to the Dapp token. Sorry, transfer some Dapp tokens to the token farm. So you'll notice that Dapp token has 1 million tokens, okay? You can see the total supply here. That number looks bigger than 1 million, but I'll explain why in a second. So I'll just do this. Say await Dapp token transfer. Okay, so this is the function on the smart contract that actually moves money from one account to another. So you can see it's where does it go and then how much. Okay, so transfer to the token farm, so token farm address, and then basically the total supply, which is 1 million tokens. So this looks like a lot more than a million, but I'll explain why. Basically, this token has 18 decimal places here. Okay, that means that like there's 18 zeros after the decimal place. So like the US dollar has $1 has 2 decimal places, 2 zeros after the decimal. Well, Ether, Ethereum and lots of tokens basically have 18. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? So that's like what instead of $1, that's what like one Dapp looks like. Okay. But also Solidity does not handle decimals. Okay. So you have to store everything like in integers basically. So that's what one Dapp token looks like when you're talking about Solidity, okay? Because there's no decimal places, and anytime you want to store tokens, you have to do them without fractions. So that's what 1 looks like, and then if you're going to do a million, 1, 2, 3, 4, 5, 6, that's what 1 million looks like, okay? So that'll be also true for Ether, and it'll also be true for DAI or mock DAI. Okay, so Dapp token transfer token farm address, then 1 million tokens. All right, so now we have put all of the Dapp tokens into the token farm, and then we want an investor to be able to deposit the tokens in the token farm to use the app. So we want them to have some DAI. Okay, because right now once we deploy the DAI, all of the tokens just belong to the person who deployed it. Okay. And so we want to transfer some to an investor. All right, we'll do that like this. So boom, boom. Transfer 100 mock DAI tokens to an investor. All right, so that'll just be the second account in the list. So if you open Ganache again, the first account is the deployer, the person who puts the contracts on the network, and then we're going to treat this second account like the investor. Okay, this is the person that's going to held some DAI and then earn Dapp tokens for using the project. Okay, this is the deployer, this is the investor, and we'll see that scenario come up here pretty soon. Right? So this is still may not make a ton of sense, but it'll all make sense in time. Okay. So you also might see this accounts 1. That's because this is an array, and an array zero-based index. So like the first one is 0, and then like the second one is 1. The third one is 2, etc., etc., etc. So that's why accounts 1 is actually the second account in the list. So if you're new to programming, that might look confusing, but that's why it looks like that. Okay, so that actually is a complete migration. So let's see if we can compile the smart contract. Say Truffle compile. Make sure we didn't make any errors. All right, moment of truth here. All right, compile successfully. Now let's try to deploy it to the blockchain. So we can say Truffle migrate -- reset. All right, so we use the reset flag here to replace the smart contracts on the blockchain, because remember that once the smart contract's on the blockchain, it's immutable code. It doesn't change. So the only thing you can really do is replace it. So that means you basically create a new copy of the smart contract and put it on the blockchain, and it gets an updated address. So really quickly, we can just say Truffle console, and we can check to make sure that the contract was deployed. We can say, let's see here, mock DAI equals, or we'll call it mDAI, lowercase m DAI equals await DAI token deployed. All right, and then we'll check the balance of the account. So say investor equals await web3.eth.get. Actually, let's do this. Say accounts equals await web3 eth get accounts. All right, so this is a function. So web3.eth.get accounts, await, and then accounts 1. Remember, I said that was what we did in the migration. So accounts 1 right here. All right. So accounts 1 is this, and we can check that in Ganache, 0x33 A18. All right. So yeah, A18. All right. Perfect. So now we can say mdi balance of, and then pass in accounts 1, and then say balance equals 08. Oops, sorry. I made a little syntax error there. Balance toString. Boom, there we go. All right, so I'll explain what I did here. So the mdi token, all right, so let's see here. Mockdi, we're gonna call it mdi. Okay, it has a balance of function, which basically allows us to see who owns how much. Okay, so balance of is actually a mapping here, but we call it public. So Solidity allows us to fetch the value of this mapping with a function like that. So mapping's a lot like an associative array in other programming languages, or like a hash table, key value store, basically, where you give it a key and it returns a value. So in this case, just the address of the person who holds the tokens, and it returns the amount of tokens that they hold up. It's a very simple concept, okay? So we can also convert that to the human readable version with decimals like this. So we can say formatted balance equals web3.utils from way, all right? And then pass in balance. Boom, there we go. So I'll explain this. Remember a second ago when I talked about, the Dapp token having 18 decimal places? Well, in Ethereum, basically that means the smallest unit of Ether, which has 18 decimal places, is way. Okay, so you can see this little chart here. Basically, 1 Ether is equal to this many way. All right, and so 100 Ether is equal to this many way, etc., etc., etc. So what we do is, tokens often hold the same decimal resolution, so you can use these same helpers like Web3.js from way on a token balance that also has 18 decimal places, and it'll work. So basically, you can say, how much is this in terms of human readable tokens, converted to decimal places, and that's how it'll work, okay? So yeah, you basically say from way, it'll give you the actual token value. So this is really helpful. We'll use this a lot throughout the tutorial. You can also do, two-way, web3.utils two-way, and we can say like 1.5 Ether, okay? And then boom, there you go. So if you want to go from decimals to no decimals, you can do it like that and just tell it the unit that you're coming from, and it will automatically convert it to the way value. This is really helpful when you're interacting with smart contracts, like I said, as we'll see in this tutorial. All right, so we have successfully created these migrations to put the new smart contract on the blockchain. It puts the Dapp token smart contract to the blockchain, the DAI token, the token farm. It gives the token farm all the Dapp tokens, and then it transfers 100 mock DAI tokens to the investor so they can actually use it. All right, so that's all the setup we need to do for now. Now what we want to do is actually go back into this project and continue building out this contract, okay? But in order to do this, we want to actually write some tests. So tests are really important whenever you're creating smart contracts, for lots of reasons. The smart contracts, you can't change the code. And so you want to make sure that they work before you put them on a blockchain. And so we can write tests to ensure that they work properly and define all the behavior that we expect. So we can write them in JavaScript like this. I'm just going to exit out of the console here. I'm going to say make dir tests. All right. So that creates a new directory inside of the project called test. And we'll say touch tests / we'll call it token farm .tests.js. Okay. So we'll write these tests inside of JavaScript, and we'll put them inside of this file here. So tests tokenfarm.js. So we've got a lot of nice libraries inside of our project already that's going to allow us to create the tests. All right. So we're going to use Chai, which is an assertion library, and Mocha, which is a testing framework for JavaScript that comes bundled with Truffle. So I'll just show you those right now. Let's see, Mocha. All right, the Mocha testing framework, and then also the Chai assertion library. So here's both of those right here. Mocha testing framework. All right. If you want to read more about that, you can go check out the documentation. And then also the chai assertion library, which is going to allow us to do things like expect, should be, chai should, etc., etc., etc. Okay. So we'll see that a lot inside the tests here. Inside this file here, see token farmer test. We'll set everything up at the top. We'll import the contracts just like we did in the migration, like this. All right, if you want to find the skeleton for this test, it should be at the the source code for this video. But boom, there you go. All right, so DAI token equals this, Dapp token, and token farm is just like the deployment script. So next, what we want to do is require chai. All right, do that like this. Require chai. That'll help us write our assertions, and then we also want to use chai as promised. So do that like this. Boom. All right, and then we also want to use should like this. Boom. Okay. So don't worry if you don't fully understand this. Basically, it's going to allow us to write better tests throughout the project. Okay. So next, what we want to do is write some basic tests like this. We use the contract keyword, contract. Okay. And then we say token farm. All right. And then we can say accounts, pass in a function here. And then what we want to do is first and foremost, just check that the smart contracts were deployed properly. So we can write tests inside of here. All right. And that's what we'll do throughout the rest of this tutorial. So the first thing we want to do is basically create the first describe block and say describe mock DAI deployment. All right. And then we pass in a function here. We'll make it async. All right. And then inside of here, we'll say it has a name. All right. And then we'll just say DAI token equals await DAI token dot new. Okay. And then we'll say, let DAI token. And then we'll say assert dot equal name equals mock DAI token. All right, so let's see if that works. Let's run the test. So before we do that, basically, we just have this contract function that says we want to describe the token farm. That's sort of the whole thing. And now we are talking about tokens inside of here too, but the main purpose of this is that the token farm works. So that's okay. Anyways, we say describe the mock DAI deployment. That's the DAI token. We just want to say it has a name. So it reads like English, describe the mock DAI deployment. And once it's successful, it has a name. All right. So let's try to run the test. We just do that like this. Truffle test. Okay. Moment of truth. We'll see if it actually works. So it compiles correctly, and then boom, it doesn't work. So asset is not defined. Let's see what the problem here is. So it looks like I just made a mistake here. So I said asset, not cert. Sorry about that. So we'll run the test again. All right, Truffle tests. So I actually like leaving these mistakes on screen because it shows you, one, I'm not perfect, and that, making mistakes is part of the development process, and you just have to learn to fix them. And tests are really helpful in doing that. Okay. So name is not defined. So, sorry, I actually forgot to fetch the name. I don't know what I'm thinking here. Const name equals await DAI token dot name. So try that. We actually got to fetch it. Okay, let's try it again. So Truffle test. And then boom, there we go. All right, so it failed, but we're getting something back. Okay, so mock DAI token, it should be this, mock DAI token. All right, capitalized. All right, try it again. And boom, there we go. Awesome. So we've written our first test. Congratulations. We want to add more tests. And in order to do that, I want to refactor this a little bit to make it easier to write more tests. Okay, so we'll take this line out. And the first thing we're going to do is create a before hook. Basically, this is going to be a function that gets run before every single test example. So we say before, and there's an async function, pass it in. All right, and then what we want to do is basically move this DAI token here. All right, and say let DAI token. All right, so, but instead of saying let right here, we want to do let here. Okay, because we want to read this variable value inside of this test example. Okay, so let's just save that and then run the test again. All right, boom, it still works. Awesome. So that's going to set us up to write a lot more tests throughout here. And so essentially what we want to do inside this before block is recreate what happens in our migration right here. Okay, so we'll do that like this. We'll basically say, let DAI token, let Dapp token, and then let token farm. All right. And then we'll say, Dapp token equals await Dapp token new. Okay. And then also token farm equals await token farm new, and then Dapp token address. And then DAI token address. All right. And then, because that's exactly what we do here. Basically, we deploy the DAI token, we deploy the Dapp token. Then once we have the addresses, we put them inside of here. Okay. So this will be, load contracts. And then next we want to transfer all tokens to the token farm. All right. All Dapp tokens. So we'll do that like this. Say await Dapp token transfer, and then we want to say this many. Let's do it in the string. All right. So now we can just rerun the test and make sure it still works. All right, so we got a little bit of an issue here. So we need to actually transfer them to someone else. So I forgot an argument here. I just did the token amount, but I didn't say where they needed to go to. So token farm.address. All right, save that. Run the test again. And there we go. Awesome, still works, perfect. So now what I wanna do is do a little bit of refactoring. So I could basically say this instead of typing this long number out. Like, it's really annoying to type this out. I can use those helpers that I showed you in the console a minute ago. Basically, I can say Web3. I can say Web3.utils two-way. All right, and then paste in 1 million 1 2 3 4 5 6, and then say ether here. That would do the trick, but we're going to do this several times in the tutorial, and I don't really want to keep typing web3.utils two-way over and over and over again. So I'm actually going to create a helper function that does that, okay? So here at the top, just below the require, I'm going to say, boom, function tokens, all right? It's going to pass in an arbitrary number of tokens, and it's just going to call this web3utils two-way function inside of it, because we're going to be converting Dapp tokens, DAI tokens, Ether over and over and over again throughout the tests, and I don't want to keep writing this. So we can just say tokens here, and then pass in 1 million. So 1, and then 1 2 3 4 5 6. Boom. All right. So next, now that we have the migration set up, we want to basically, well, actually, the next thing we want to do is transfer some tokens to the investor. Okay. So we'll do that like this. So after transfer tokens here, we can transfer investor tokens like this. So really that's going to look like this. Accounts 1, and then accounts 2. Okay. So we send tokens to the investor like this. So we say DAI token transfer to accounts 1, and we transfer 1 million. All right, or sorry, 100. But inside the test, you have to also pass in the function metadata that explains who is calling the function. Okay, so basically said DAI token transfer 100 tokens to account 1. That's gonna be the investor. Again, we have accounts are coming in from here. All right, so whenever we create this contract, we have access to accounts just like we did in the deployment script. Okay, So we transfer 100 tokens to account 1, but we have to tell it who it's coming from, because inside the test, we want to be explicit about who is doing that. So basically, like, here's all the arguments in the function. Basically, you can add an additional comma and then create an object right here and say from, and say accounts 0, because that's the person who deployed the DAI token to the network. And if you look in the code, basically we assigned that person all the tokens. Okay. I'm going to take this a step further, and instead of having, accounts as an array here, I'm actually going to break it out and say owner and then investor. Okay, so the owner is going to be the person who deployed the Dapp token to the network, all right? And then the investor is going to be the person who purchases, who uses the bank and distributes, who deposits DAI, holds the DAI, deposits into the bank, and then earns Dapp tokens. So we can transfer 100 tokens to the investor, and then it's going to be from the owner. Okay. So that keeps us from having to say like account 0, account 1. It makes a lot more sense whenever we write the tests about like which account is doing certain things and which one is, receiving things, especially when we're talking about transferring money around. Okay. So now that's set up, let's just run the test again, make sure it still works. All right, works. So now we want to basically describe the Dapp token. We'll say the Dapp token. All right, it has a name. Say constant name, Dapp token. Let's say Dapp token. Run the tests. All right. And then next we want to test the basic token farm deployment. Okay. So we'll say describe token farm deployment. And it has a name. So we'll say token farm. And we'll say Dapp token farm. And while we're here, I actually want to write one more test. Okay. So what I want to do is make sure that it actually has all the tokens transferred to it. Okay. So write this test like this. We'll say contract has tokens. Okay. We'll say let balance equals await Dapp token. All right. Balance of. We pass in the token farm address. Okay. And then we assert that the balance is equal to 1 million tokens, which is the total supply of Dapp. Okay. So we'll run the test like this, and this will check the last 2 tests that we just added for the name and also the balance. See if it works. And so a little bit of failure here. So it doesn't have a capital A here. That's okay. So just kill that. Try it again. And boom, there we go. It has a name, and the contract actually has the correct number of tokens. So that is a successful first test to make sure that it's all set up properly. All right, so now what we want to do is continue on building out the smart contract for the token farm. All right, we've got everything set up here. We have a token farm smart contract. We have the DAI token and the Dapp token smart contracts. And we have, a test where we can check the behavior and make sure that the smart contracts work properly. Okay, so it might be a little boring so far because we've got so much to set up, but we're all set up at this point. And now we're actually going to write the more exciting code for the smart contract to make it work. So we need to do a couple things here. One will be stake tokens. So this is basically where an investor will deposit the DAI into the smart contract to start earning rewards. 2 will be unstaking tokens. Well, maybe, yeah, but the order we'll see what order we actually do these in. But 3 will be issuing tokens. So these will be 3 different functions that we create. One, like I said, an investor can put money into the app. All right, and then they can also withdraw money from the app. This is the same thing as deposit. And then also withdraw. Okay, and then issue tokens will be essentially earning interest. So this will be a function that can get called by the owner of the contract, which we'll set up, and they can, do that on a regular interval or whatever. Okay. We'll create the first function like this for staking tokens. We'll use the function keyword. We'll say function stake tokens. All right, we'll say uint underscore amount in public like this. Okay, so we'll write all the code in here. So this is a function in Solidity, all right? It looks a lot like this special constructor function here, but it works differently. So this is just a generic function that we write. We gave it a name. It's called stake tokens. We use this function keyword to declare it. Stake tokens is the name. And then we give it some arguments, just like we did our constructor function up here, okay? So it has one argument, which is just the amount of tokens to stake. And then we use this public visibility here so that this function can be called by someone else outside the smart contract itself. Okay, so the core thing that we want this to do is basically transfer the DAI tokens from the investor's wallet to this smart contract right here. Okay, so, don't forget our graph here. Basically, an investor takes DAI tokens and they send them to this token farm. And then while the tokens actually live inside this token farm and digital bank, they can earn these Dapp tokens. So the core functionality of this specific function is to allow the investor to do that. So we transfer tokens to this smart contract like this. We'll say transfer mock DAI tokens to this contract for staking. We say DAI token, all right, because we have that variable here, all right, DAI token transfer from, okay, MSG sender address this, and then amount. So let me break that down. That might look a little confusing at first, but I'll explain what it means, okay? DAI token has a transfer from function. Okay, I'll pull that up. All ERC20 tokens do. Basically, what it allows it to do is let someone else move tokens for you. Okay, so because we're calling this inside of this stake tokens function, it allows the allows the contract to actually move the funds on the behalf of the investor, okay? So it's different from the transfer function. This is a function that gets called like anytime the token holder themselves spends the tokens, but transfer from is basically a delegated transfer where it allows, somebody else to spend tokens for them, sort of like a smart contract, just like we're doing inside of here. And we'll see this here in a minute, but the investor must approve the tokens before they can actually stake them, which we'll see that in the test here in a minute, which allows this transfer from function to get called inside of the smart contract, okay? So MSG.sender is a special variable inside of Solidity. So MSG or message is a global variable inside of Solidity that just corresponds to the message that's being sent whenever the function's called. And sender is the person who initiated that. So the person who's calling the function, okay? And then the second argument is the address actually of this token farm smart contract. So basically this corresponds to the smart contract itself, and then we convert that to an address type, and then we pass in the amount, okay? So you look at the transfer from function. Who's it coming from? Well, the investor, the person who's calling the function, all right? The second argument is who is it going to? Well, the address of this smart contract, the token farm. And then how many? Well, the amount that gets passed in whenever we call the function, okay? So that's the core functionality of staking tokens, is basically to transfer tokens from the investor's wallet to the token farm smart contract. And so in this hypothetical scenario, basically the tokens are just going to live inside the app in a real world project. They could be used for like lending and borrowing, all that kind of stuff, like once they're actually deposited. But this would be just a simple kind of scenario to show you what it looks like to create a very basic version of that, okay? So that's all that's going to happen is the tokens are going to be transferred to the smart contract for now, okay? So in order to do that, we also have to keep track of a lot of things. We need to know how many tokens are inside of here. We need to actually say that the user is staking tokens, that they have a staking balance. So we'll do that here. We'll create a special mapping for that, okay? So a mapping inside of Solidity is a key value store. So mapping, it's a data structure, which basically has a key and a value. So key value looks like this. Basically key and then value. So mapping basically says, like, give me the key and I'll return the value. So the mapping in this case is an address, okay? So the investor is going to be the key, their address. And then the value is going to be how many tokens they are currently staking, okay? So we're basically just going to update that with the amount that gets passed in. So I'll show you what that looks like. So mapping, address, like this, uint, we'll call it public, staking balance, okay? So we'll update it like this. We'll say update staking balance, and we'll say staking balance msg.sender. And we could just say, you know, equals amount right here, all right? So I'll even bump the font up a little bit so you can see that better. You know, staking balance equals the amount that we get passed in, okay? But theoretically, they could call this function more than once. So we want to say staking balance equals staking balance add, and then amount, okay? So that's how you write to a mapping. Basically, you just use these, you know, braces right here, and or brackets, I should say, and then you pass in the key, and then you say the value is equal to, you know, whatever value you want to assign that to. So in this case, you're just taking the existing staking balance and adding the amount that gets passed in here, okay? Next, we want to tell the app that the user has staked, okay? And this, you'll see why here in a minute. So we do that like this. We create another mapping that just says mapping address, and the value will just be a Boolean, so true or false. Bool, that's what bool stands for, is Boolean. Public has staked. All right, and then we also want to create an array that keeps track of all the addresses that have ever staked. Okay, so address, array, public, stakers. So what is an array? So an array is just a list, basically, inside Solidity. It's a sorted list. So an array can look like this, like, you know, 1, 2, 3, 4, 5, right? So an array can look like this, you know, apple, banana, carrot, okay? So an array can also look like an array of addresses. So 0x0, you know, 0xf43, you know, 0x12a. You get what I'm saying? So basically, like, it's just a list containing these brackets that contain different items, okay, and sorted. So in this case, we're going to create an array of addresses, and this is going to be people who have ever staked inside the app. And we want to keep track of all those people because we need to issue them rewards later. We need to know who's doing it, okay? And then we also have this hash mapping that keeps track of people who have ever staked. So I'll show you why. We'll do it like this. Say updates. Add users, stakers array, if or only if they haven't staked already. So we need to do this because it could mess up if they stake more than once. Okay, so if Bang has staked, msg.sender, let me say stakers push msg.sender. Okay, so basically, you know, let me just like skip this part for now. Like, let's just comment this out. Basically, we wanted to update the staking balance. We could just do that like this and say, you know, boom, when they stake the tokens, transfer tokens to the app, set their staking balance, and then add them to the stakers array. But the real problem is if they call this function more than once, like they might get added more than once to this array, okay? And we're going to use this array to determine who gets tokens later, and we don't want them to be double counted. We don't want them to get issued more than one token. All right. So basically, that's why we use this. If has staked, then put them in there. If not, then no. So this if statement is just a conditional. So it basically says if basically it's going to run like if true, then this will happen. If false, then this won't happen. Okay. So in this case, we want to say if they have staked, or if they haven't staked, then do this. So that's what this bang means. So bang does the opposite. So we could say if false, bang false will evaluate to true, and then this will run. So if I say if bang true, then it won't run because it'll be the opposite, which will be false, and then this won't happen. So I'm going to just clarify that and then go back to what we had. Okay. So if they have never staked, then add them to the stakers array. That's what that means. Okay. So let's see here. The last thing we want to do is actually update 2 more values. Let's see here. If we want to say it has staked, so has staked msg.sender. We always want to update that whenever they call the function. Okay. So update staking status. And then lastly, we want to make a mapping that determines their current staking status. So basically like is staking. It's kind of annoying that we have to define all these states inside Solidity, but that's just the nature of the programming language. So we'll say is staking. All right. And then has staked. Okay. So that is our complete staking function. Okay. So now what we want to do is actually write some tests for this to see if it works. So we'll go to the token farm tests, and we'll create a new function inside of here. We'll call it like this. Say describe. Say farming tokens. As an async. We'll pass in a function here, and we'll say it rewards investors for staking mDAI tokens. And we'll say async, pass in the function here. All right. So we'll just test the basic depositing functionality. All right. So we'll say let results. We'll go ahead and define a variable at the top. Okay. And then I'm going to give us some space here. We'll say results equals await DAI token balance of investor. So what we want to do first is just check the DAI token balance before they deposit tokens into the app. And then we want to make sure that it goes down after they deposit it into the app. Okay. So we'll say, check investor balance before staking. And then we'll say assert equal, all right, result to string. And we want to say tokens 100. So that it's 100 DAI tokens before they stake. And then we can create a message like this. So if the test fails, we know what happened. Boom. So investor mock DAI wallet balance correct before staking. So I'm going to kill the file tree here so we can see that all on screen, right? So let's just run the test. Truffle test. I probably made something wrong. I probably made a mistake somewhere at this point. So this will tell us if we did. Oh, nope. It worked. Awesome. Very cool. So you can watch it fail. We can, do like 10 here and watch the error message in play. All right, boom. So it failed, and you can see an investor mock DAI wallet balance should be correct, and that helps us know like where the failure message is. So now what we want to do is actually stake the DAI tokens. We actually want to call that function. and we want to check the result afterward. So we've ensured that the result is correct before we call the stake tokens function, but now we actually want to call it and then check for the result after to make sure the tokens were supplied to the smart contract, that the staking balance was updated and all that kind of stuff, okay? We'll do that like this. We'll say check staking results. Well, actually, let's stake the tokens first. Say stake mock DAI tokens. And we'll just say await. Oh, actually, sorry. Well, no, I'll show you right now. Await token farm stake tokens. And we pass in 100 tokens. And then we tell it who it's coming from. Say, from investor. Okay. And so now I'm going to run the test, but I'm going to make it fail on purpose, okay, to illustrate a point here, all right? It's going to fail, and I'll show you why. So we'll run the test, and not for the same reason that it was failing earlier. So this will actually pass, and then we'll get a new failure. All right, so it says VM exception, while processing transaction, revert, okay? So why did that happen? Well, remember, inside of here, we called the transfer from function. And if you're paying attention closely, you might have remembered me say that you have to approve the tokens before you can transfer them to the app. So again, transfer from is a function that lets somebody else spend the tokens. So the smart contract is actually spending the tokens for us. So what we need to do is tell the Dapp token that tell the DAI token, I'm looking at the wrong contract here, but it's the same idea. Tell the DAI token that the Dapp token farm is allowed to spend tokens for us, all right? So we have to call this approve function on the token before we do that. We'll do that in the client-side application when we build it out later, but we also must do it inside the test. So what we'll do is say await DAI token approve the token farm.address, and we want to approve 100 tokens. All right, that's what we do. We call that function. Basically, we say the token farm can spend 100 tokens for us, and that's how we do it into the test. So it's a two-step process for staking. We approve the tokens, and then we stake them. All right, so let's run the test, see if it works. Hopefully the error will go away. All right, boom, it worked. All right, so now what we want to do is check for the result after staking. So the first thing we want to do is make sure that the investor wallet balance is correct. So we'll do that like this. I'll just paste this in here. So the check for the balance of the DAI token. So DAI token balance of investor. All right. We want to say it's equal to 0 because they shouldn't have any tokens left in their wallet after they've staked 100. And then we want to make sure that the balance for the token farm is correct, that it now has 100 tokens because 100 tokens moved from the wallet to the app. All right, so we'll do that. Run the test. All right, that worked. So now what we want to do is make sure that the staking balance is correct. So it should also be 100 because remember we added that here. Here, the staking balance. All right, and then we just check for that here. So we make sure the staking balance is correct. So token farm, staking balance, investor. And then lastly, we want to check that the investor is staking. So that's the current status, because that's the other important thing here is that they are staking. So they have a staking balance and their current staking status is true. Okay. So do that like this. So result equals await token farm is staking investor. All right. So true. All right. So now let's run those tests, see if it works. Awesome. So now we have all the tests that we need for this staking tokens function. So that's going to be all we're going to do in this section. In the next section, we're going to keep going and we're going to finish issuing tokens for people who have staked them, basically distribute Dapp tokens as interest, and then also allow the investor to unstake their tokens from the app. All right, now what we want to do is allow the app to issue people tokens as a reward for staking, okay? Or issue tokens, issue staking rewards, give them interest basically for using the app, okay? So just to, quick recap, basically, investors are going to deposit DAI tokens into the token farm, going to stake them, okay? And they're going to earn Dapp tokens for doing that, okay? And that's because, the token farm now has all the Dapp tokens, and we can create a function to issue those to the investors, okay? So we'll create a function like this. So, this is actually going to be item number 2 instead of item number 3, okay? So we'll just take this out, put it here. We can do that, and then just take the numbers away. Because that's not necessarily the order we'll do them in. All right, so issuing tokens, we'll create a function like this. We'll say function issue tokens. And then we'll say public, because we want to be able to get called outside of the function. And we'll say, what we're going to do inside of here is basically loop through all the people who have staked inside of this stakers array, and we're going to issue them. All right, so we can do that with something called a for loop. All right, so I'll pull that up here. So basically, Solidity allows you to create things called loops. All right, where basically you can iterate over items in an array and do something with them. Okay, so let's see. It's not really pulling it up. Here you go. Okay. So here's an example of a for loop. So basically, you basically say for each item in an array, do this thing. So in our code, we'll do it like this. We'll basically say for uint equals 1 equals 0, I is less than stakers length, I plus plus. Okay, so this is what the basic for loop is going to look like in Solidity. Basically, it starts off with a variable called I. I is going to be the iterator, and it's going to start off at 0. And then so basically, for each number I all the way up to the staker's length of the array, we want to do something, and after the loop runs, we want to increment that number. So that might be really confusing, but let me just, it's basically what it's saying is like, we have this array of stakers just like this, okay? So let's just say that this is the stakers array. Let's just copy it and paste it, okay? So we'll create some new text down here. Let's say this is the stakers array, and paste it in. So this has three addresses in it, okay? The first one's going to be address with the index of 0. The second one's going to be an address with the index of 1. And the third one's going to be an address with the index of 3, okay? So basically, that means that you can loop through this and create a variable called I, okay? And we start off with I equaling 0, all right? And then we run this for loop, okay? We basically say, starting off with 0, do something inside of here, and we'll have access to a variable called I. And the first time this loop runs, it runs over and over again for each item in the collection, okay? So basically it's saying for I equals 0 up to the staker's length, so the staker's length will be, sorry, this was supposed to be 2 right here. Sorry, 2. That's not very good. The staker's length is 3. So for 0, 1, 2, 3. All right. Or actually, that's a little confusing. It doesn't go up to 3. It goes until it's less than that length. So it'll run 3 times, but for 0, 1, and 2. So I made some mistakes here. This is going to get really confusing, but this is the address 0, 1, and then 2. I starts off at 0, and then until while it's less than the actual length, it's just 3. So for 0, 1, 2, we're going to run inside this loop. Okay. So basically we'll have access to I inside of here, and we say stakers at index of I. So that's going to be the current address. We'll say address recipient, okay, equals stakers I. Okay, so that basically now we're going to have an investor that we can issue tokens to. And we'll just say, we'll get the balance. So we'll say uint balance equals staking balance. And then we'll get the recipient. So basically what we're going to do is find out how many tokens they've staked, and we'll issue them that same amount of Dapp tokens. So basically, if they deposit 1 DAI, they get 1 Dapp token. If they deposit 100 DAI, they get 100 Dapp tokens, okay? So we'll just say Dapp token, transfer, recipient, and then balance. Boom. That's all we have to do. So basically it's 1-to-1. So for each item in the stakers array, for every person, for basically you can read it like English. For every person who's staked inside the app, fetch their balance and then send them the exact same amount of DAI tokens, or Dapp tokens, I should say. Okay. Now, we only want to do this if their balance is greater than 0. Okay. So if they have withdrawn their funds from the app, we don't want to send them tokens. And then we have the additional protection of, all the business logic we've added here to make sure that they're not, doing that and that they are currently staking. Okay. So the next thing that we want to do is make sure that we need to back up a step, because we want to require that the person's balance actually exists whenever they stake tokens. So we want to do this at the top of the function. So I forgot to do this in the last section, but that's okay. We'll just add it here. So basically, we want to require that the amount that they're staking is greater than 0. So it requires a function inside Solidity. Basically, if this evaluates to true, then the function will continue running. If it evaluates to false, then the function will stop. It'll raise an exception. It'll surface this message, and then none of this code will run after it. The transaction will totally fail. Okay. So basically, we just want to make sure that they pass in an amount that's greater than 0, because we don't want them to stake 0 tokens and then get added to the stakers array, et cetera, and then, we basically don't want to worry about them inside this function here. Okay. So the last thing we want to do inside of here is require that only the owner of this application can call this issue tokens function. So what do I mean by that? Well, whenever this is a public function, so basically anybody could call this and issue tokens as much as they wanted to. So the whole idea here is that this is going to be an app that is permissioned basically by an owner, and the owner probably has some sort of set schedule where they issue tokens. Maybe it's every day, maybe it's every block, maybe it's every week, year, whatever. Okay. We only want the owner of the contract to be able to issue them. So we can restrict who does that like this. All right. So we can say require msg.sender. So the person calling the function equals owner. All right. And we can say caller must be the owner. All right. And then we need to keep track of the owner whenever we deploy the contract. Basically, we can just say owner equals msg.sender. So this is the person who deployed the contract. And then we'll create a state variable to track the owner like this. We'll basically just say address owner equals, well, we'll just declare it. We won't actually assign it yet. But we'll call it public. Okay. And then we'll put it at the top. All right, so we'll create a state variable for the owner. We'll assign the owner upon deployment, and then we will require that the owner is the only person that can issue tokens. All right. So that should work just fine. We can add some comments here so this makes more sense. All right. We'll just say the owner is the only person that calls the function. And then we'll also say issue tokens to all stakers. All right. So now let's see if it compiles. Make sure I didn't make any mistakes. I might have. We'll see. Okay. So yeah, we had a little issue here. So balance. I made a typo. All right, start again. All right, boom, it compiles. So now let's write a test for issuing tokens. All right. So inside the token farm, we'll go down after here. And we'll say issue tokens like this. And I'll just paste this in. Boom. So we'll just say await token farms issue tokens, and we'll call it from the owner. All right. So remember we added the owner here. The person who deployed the contracts is the first address in the list. All right. So from the owner. And then we'll also ensure, we'll make sure that the balances are correct after the tokens were issued. So we'll make sure that the investor balance, we'll just fetch it like this. And we'll make sure that it's 100 tokens because, they deposited 100 tokens into the app. And then every time new tokens are issued, they should get 100 Dapp tokens because that's what we did. We did a 1-to-1 issuance. So if they, put in 1 token, they get back 1 token. If they put in 100 tokens and they put in, they get back 100 tokens. So we got our error message there. And then lastly, what we want to do is make sure that the owner is the only person that can call the function like this. So basically we can say ensure the owner is the only one that can issue tokens. And we can try to issue it from someone else. Like we can see if the investor can call the function. And if he tries to, then it should be rejected. Okay. So we'll run the test like this, Truffle test. Moment of truth. All right. So we got a problem here. So issue tokens is not a function. So let's see. I might have made a mistake here. Issue token. So it needs to be plural. All right. Try it again. That was my mistake inside the smart contract. All right, boom, it works. So the test passes. That means that our code works. So we issue the tokens. The balance is correct after they've done it. And then nobody else but the owner can call that function. So we're almost done with this smart contract, okay? We added the ability to stake tokens so people can deposit them into the app. The issue tokens function happens so they can earn interest basically and earn new tokens. The last thing we want to do is allow the investor to remove tokens from the application, okay? So it's pretty straightforward. Basically, we just do the opposite of we did with stake tokens, okay? So this is the withdrawal. So we say function unstake tokens. All right, and then public. So pretty straightforward. First, we want to fetch the balance. So say, do it like this, fetch the staking balance. Okay, so we want to do it based on the amount that they've staked into the app, okay? Because, we don't want them to pass in an arbitrary amount. We want the app to be the source of truth for how much, they've actually deposited. And then we want to make sure that the amount can't be, greater than 0. All right. Or that it is greater than 0. We don't want them to try to withdraw 0 tokens. And then next what we do is we transfer tokens instead of from the user to the app, we transfer it from the app back to the user. Okay. So we do DAI token transfer to msg.sender, the person calling the function, and then the balance. All right, but we do it based on their balance from the app. Okay, so their balance, transfer it back to the user. Then next, we reset the staking balance, okay, like this. So boom, set their staking balance is now 0 because they've withdrawn all of the tokens from the app. And then we say that they are not staking anymore, like this. Basically say, is staking, false, okay? So unstaked tokens, pretty straightforward. We fetch the balance from the staking balance mapping. All right. We make sure that it's greater than 0. We transfer the tokens back to the user. We update their staking balance to 0 because we just drained the entire thing. Okay. And then we set their staking status to false. All right. So that's all the code for the smart contract. We can write, just this last few tests like this. Basically, we will unstake the tokens. Boom. All right. And then we'll basically make sure that check the results after staking, make sure that they receive the tokens. So the DAI token balance of the investor is now 100. They withdrew all the tokens out of the app. All right. Now we'll say the DAI token balance of the farm address is 0 because they withdrew all the tokens. All right. And then the token farm address staking balance of the investor is now 0. And then lastly, the investor is no longer staking. All right. That's the last test example. Say this. All right. So now I'll clear out this dead space here before we try to run the test, just to clean up the code. And that should be a complete test suite, all right? So we'll do Truffle test and see if it works. All right, boom, there we go. It works. So that is our complete smart contract for the Dapp token farm. And that is, that's a complete test suite as well. So while we're here, I want to do one last thing, all right? Because this is something that we're going to need whenever we create the front-end application. I'm going to create a script that allows the deployer to issue tokens, okay? So basically, we're going to create this script that says, that allows us to call this function, okay? So, because what I don't want to do is open the console every time and, call this function. Basically, Truffle allows us to write scripts where we can run them from our command line and issue tokens that way, okay? So just like in the migration, we set this up to go ahead and give, an investor 100 tokens. Well, we also want to create a separate script that we can run anytime we want to issue tokens from the deployer. So I'll go ahead and say make dir scripts. All right. Sorry, I misspelled that. And then touch scripts. We'll call this issue tokens.js. Okay. So now inside of here, go to scripts, issue tokens. So we're going to create something that looks a lot like our migration script here, but it's going to work a little bit differently. So we'll say, let me find this. We'll pull in the token farm, so we'll copy that. All right, and then we'll do this module exports, okay? We'll just copy this and paste it. Oops. But instead of all these functions, we'll say callback. All right, so this will be the template for our script. Basically, Truffle allows us to write scripts where it loads our entire app up. We can import the smart contract like this, and we use this module exports function, okay? And then all we have to do is call a callback inside of here. And then we can, write any code here. Okay, so what we'll do is create a console log that says, tokens issued. So I'll show you a real basic thing. We can just run the script like this. Truffle exec scripts issue tokens. All right. So we're not going to do anything. It's just going to run it and log to the console. Yeah. So tokens issued. Awesome. So that works. But now what we want to do is basically say token farm, let token farm equals await token farm not deployed. And then await token farm issue tokens. All right. And then boom, there we go. So right now we can actually call that function. We can run the migrations again. Say truffle migrate. All right. Dash reset. And we can also run the script again. And it's not actually going to issue any tokens because no one has deposited it into the app, but we can just, run it and make sure that it doesn't fail. Okay. Boom, there we go. Awesome. So our script is working. We'll revisit that whenever we build the client-side application and allow people to actually interact with the application and, deposit tokens into it. we'll run the script so that people who have deposited it into the app earn those tokens. And I'll catch you in that next section. All right, so now we've completed all the smart contracts for the tutorial. And what we want to do now is set up the front-end website or the client-side website to interact with those smart contracts, let people stake tokens into the app, and start earning rewards for doing that, okay? So first, let's just do a little bit of housekeeping. Let's migrate the smart contracts to the blockchain, make sure that Ganache is running, okay? So we'll say Truffle migrate -- reset, okay? That's going to put new smart contracts on the blockchain, all right? And we want to run the server to make sure that the website works, okay? So I'm going to open a new terminal tab here and start the server process like this. Say npm run start, okay? And that's going to start a server and then open a new tab for the website. So it should pop up automatically for you. Check the status here. Okay, boom, done. All right, there we go. So here you can see a template, all right? This is a website template already for us. It has the Dapp token farm here and the nice little farmer on the nav bar. It's got a placeholder address, which we'll fill in later. And then also this, of course, hello world. So we can edit all this stuff, and that's exactly what we're gonna do in this tutorial. But I've created some placeholder code here so that you don't have to write everything yourself, okay? Save us some time, and it'll help us concentrate on the important parts of the tutorial rather than just, pedantically doing every single thing. So we'll go into the source directory, all right? So source, and we'll go to the components directory and then look at app.js. So I'm gonna kind of minimize this a little bit. This is a React component, okay? And this is where all of the code is for what you see right here. So I'll explain what I mean by that. So React is the JavaScript framework that we're gonna use to create the client-side website. So React is not a programming language. It's a framework for writing JavaScript, which basically means that it allows us to do things in JavaScript without having to write a bunch of extra code ourselves, okay? So React has got nothing to do with blockchain, but you can use it to build blockchain-based applications. It's just a really popular JavaScript library for building user interfaces, as they tell you right here. And I like it a lot. A lot of people in the blockchain Ethereum community use it as well. If you're trying to get a blockchain developer job, it's really great to know how to use React, okay? So React has several different things about it that are important to understand. It uses components. Components are just ways that we organize the code into reusable, logical groupings, okay? And inside the components, we write JavaScript. So this language right here is JavaScript. We can also mix in HTML. So you can see this div, right? That's HTML. And then you can also put JavaScript inside of that as well with these curly braces where we say this.props.name. That's basically putting JavaScript inside of HTML code. And this HTML code is also inside of this JavaScript, inside this React component, okay? So that's the first thing to know is how React components work. The next is the React state object. We'll see that in play. So basically, state is just a way of letting your application have data, okay? So for example, if you had a to-do list right here, you want to know how many items actually exist on the to-do list. And you want to say item 1. You want to add the item and then say item 2. All right, and click add item. So how does it know where these items are stored? Well, it stores them inside this React state object right here, okay? So you can create one inside a constructor function, a lot like the constructor function we just saw in the Solidity smart contract that we wrote, okay? And we can create a state object like this that contains all the items, okay? And whenever you add the items to the to-do list, then it stores it inside of this items array from this state object with this set state function. So set state, and then add items like this, okay? So we'll see that at play for sure inside this tutorial. And yeah, that's pretty much all you need to know for now. Basically, have an understanding of how React components work. and then how the state works. So we've got those two basic things inside of here. App.js is the main component that we'll use in this tutorial. And then you can see we already have some state set up. We have the basic account, okay? So 0x0, we'll actually change this later, okay? But here's some state. So we have an account set up, and then we have an additional component, all right? So right here is the nav bar. So this is a different React component, and we actually render that out onto the page by passing, by calling the nav bar right here, okay? And then we pass in the account from the state like this. See, account equals, this dot state dot account, okay, which is, by default this. And so then that gets rendered down onto the page right here with this dot props dot account. So props are basically the properties of the component, or the sort of function arguments. You can think about it that way whenever you create a new component. So anytime you do like account, this is a prop. So we attached a prop to the nav bar, and we passed in this dot state dot account down to the nav bar right here. So this dot props dot account. This dot state dot account. Okay. So we have two components, the app and the nav bar. We have some state, and then we pass the state on account. So I'm kind of belaboring that over and over again, but I just want to, show you how that works. If you're brand new, you've never used React before, those are the basic ideas that we need to understand. Okay. So, we will definitely build this out, but the first thing we need to do is actually connect our application to the blockchain. And that's what we use the Web3.js library for, right? So, Ethereum has Web3.js, which is the main JavaScript library for interacting with Ethereum. And it allows you to basically turn this web application into a blockchain-based application and establish a connection to our Ganache blockchain that we've got running here in the background. So we're going to use Web3 here in a minute to do that. But also, first we need to we also need to basically connect to our app with MetaMask, because don't forget, whenever you interact with a blockchain app, you need an Ethereum wallet installed, you need MetaMask installed, and you need to have your accounts added to the application. So what we want to do is use the app on behalf of the investor. Okay, so we want to find the second address in the list, reveal the private key, all right, copy it, and then go back to MetaMask and click on this little icon right here. The account icon. And you want to click on import account, okay? And then you want to paste in the private key, okay? So I've already done that, so it's going to tell me I haven't done it. But once you have, it will show the account right here, okay? So I've just named mine Ganache number 2, because that helps me remember that it's the second account in the list for Ganache, okay? But you definitely want to import your account inside there in order to use it, okay? So next, you want to make sure you connect Ganache to MetaMask. So you'll see multiple networks here. Like if you just installed MetaMask for the first time, it's probably connected to the main Ethereum network, but it supports multiple networks here. So you can, if you have localhost port 7545 already available to you, then you can select that. All right. If not, you can do custom RPC, and you can even name it Ganache like I have. And then just copy and paste the URL from Ganache. So do this, and then go here. Custom RPC, Ganache. All right, and then paste it in. And then anything else you want to is fine, and click save. Now I've already done this, so it's going to say, hey, you can't do that. But that's how you add a new network called Ganache. So just make sure you have some sort of connection to localhost 7545, and then import your account, and you should be ready to go. So now we have that, and we want to connect the app to Web3. We'll do it like this, okay? Basically, we'll create a new function called load Web3, like this. So I'm actually just going to copy and paste, because I've done this in a lot of my other tutorials, and it's also a very common pattern that's used by MetaMask. So I'll just show you. All right, do like this. Boom, load Web3. So I will kill the file tray here so you can see this better. This function connects the app to the blockchain. So don't worry if you don't understand everything that's happening inside of here. These are literally the instructions that MetaMask gives us to, connect the app to the blockchain. I'll even show you. Let's see, MetaMask, Web3. So like if you like go Google search like how to use MetaMask inside Web3, it'll even show you, well, that's not it. Hold on, let me find it. MetaMask. Okay. If you find any instructions out there, like you'll just see this pattern of like, this basically is the same thing that everybody does. So that's why you don't need to code this out by hand. You can just use my instructions. You can even find this in the final project code in the GitHub description, and you can just paste it into the app like this. So basically what it does, if an Ethereum object exists, we use the Web3 connection that way. If a Web3 object exists, then we use the Web3 provider that way. And if not, we'll say, hey, you need to install MetaMask in order to use this app, okay? So we'll call this function. So we defined it, but we haven't called it yet. So we'll say async component will mount. And then inside of here, we'll say await this .load web3. So let me explain what that means. Basically, this component will mount is a lifecycle function inside of React. So let's see, will mount. So they don't have any examples on their homepage, but I'll just show you component will mount. Sorry, I'm looking it up offline here. So basically, I'll show you right here. Basically, React has these lifecycle callbacks. Basically, when the component's getting rendered before it gets put on the page, we can call this function. And inside of here, we'll actually call the load web3 function. So we have to say this .load web3 in order to access it. But we'll connect to MetaMask that way. So we'll save that and go back to our website here. Let's see here. All right, so Web3 is not defined, so my bad. We need to actually import it. So we've saved it into our project inside the package.json file, but we need to import Web3 like this. So boom, import Web3 from Web3. And then refresh the page. Should refresh automatically, but sometimes I just refresh out of habit. So you can see what's happening in your server process, and then boom, it's compiled successfully. All right, so I'm gonna just check the console, make sure there's no warnings or errors. So I'll open the console like this. You could also do inspect element, I believe. Inspect element, inspect, and then go to the console like this. So it's got some warnings here, but that's okay. Don't worry about that. They're not actually errors. So what we'll do is now that it's connected to the app, we'll create a new function called load blockchain data. Await this .load blockchain data. So we'll call it and then we'll define it. We'll say async load blockchain data like this. And then what we'll do is fetch the account. So first we'll say const web3 equals window.web3, because don't forget we attached web3 to the window here. And we'll fetch the accounts. So we did this inside the console earlier, but you'll see how it works. We'll say const accounts equals await web3 eth.get accounts. All right. And then we'll just console.log the accounts here, so you can see. And then boom, there we go. We can see that the account was logged to the console here. So this is the exact same account that's here in MetaMask, which should also should match the exact same account here in Ganache. So A18. Awesome. So now, instead of just logging it to the console, we're going to go back and put it in the state object. So remember I was showing you earlier that React has this state object like the to-do list here. We're going to manage our own state object that will hold like the account. It'll hold the smart contracts. It'll hold all kinds of data. It'll be like our database inside the front-end application. So we can use this set state function like this. So this.set state, and then we can just pass in the value. So we have the default account here set to 0x0, which is let's see, this right here. It's really small, but basically what we'll do is instead of console log, we'll say this set state. All right, and then we pass in an object, and we say account equals accounts, and it's an array. Okay, so we want to get the first item out of the list, which is index 0. Okay, say this set state, and then that will update this account to the actual account provided by MetaMask, and then we'll pass that down to the nav bar, and we should see it appear on the page. All right, boom, there we go. We can see our account has been listed, right here in the nav bar. Perfect. All right, so now what we want to do is add some more default values to this state object here, and we're going to fill them in with data from the blockchain, okay? So I'm just going to paste these in here. You can grab this from the final code solution if you want to, but we'll update the list to look like this. Boom. All right, so we can make that account 0x0. But what we're going to do is load the DAI token smart contract and store it in the state. We'll load the Dapp token, the token farm. Okay, those will all be smart contracts. And then we'll get the balance, all right, of the user who's connected to the app. We'll fetch their DAI token balance and also their Dapp token balance. Okay, so 2 different token balances. And then the staking balance, how much they've deposited into the app. Okay. And then last, we'll keep track of the loading status. Okay. So I'll show you what I mean by that. So basically, like we'll hydrate the state, or we'll fill in all these values inside this load blockchain data. So basically, this function's fetching all the data from the blockchain, and then we're going to put it inside the state. Okay. So the first thing we want to do is load these smart contracts up. Okay. So in order to do that, we need to determine the network that we're connected to. So MetaMask, lets you choose multiple networks. We want to fetch the Ganache network, okay, and then fetch the smart contracts that are deployed to that particular network, because the contracts could be on any network. They could be on the main net, some other test network, but we want the ones on Ganache. So I'll show you why. Because basically, these ABIs inside of here, like the Dapp token, for example, it has multiple networks. If you scroll to the bottom, you look at networks. 5777 is the network ID for Ganache, okay? And that's what we want to fetch out of whenever we load the smart contract into the app, okay? So we can detect the network inside of the app with Web3 like this. Basically, we say network ID. All right, we'll do it like this. Const network ID equals await Web3 ETH net get ID. All right, we can console log that. Network ID. Save that. Boom, there we go. 5777. Perfect. And then now we can load the DAI token from this ABI file that I showed you a second ago. So this is going to get a little crazy. Don't worry if you don't totally understand this at first. I'll explain it. That's okay. So we'll just do it like this. Actually, let's do the DAI token. Boom. All right. So let me show you what it does. Basically, it takes the DAI token out of that file. So we need to import it from the top. So just below Web3, we'll do it like this. All right, import DAI token from the ABIs. And then we will literally just take the JSON from that file, find the network's key, pass in the network ID, and that will give us the address, because we need 2 things in order to create a JavaScript version of this smart contract with Web3. We need the ABI, and we need the address. So the address, we fetch it like this, and then the basically we say, if that exists, this if-else statement, then create a Web3 version of it, and if not, alert that the contract hasn't been deployed to the network. So let me step through that one by one. It's a little confusing, but I'll explain it. So we're going to create a JavaScript version of the smart contract with Web3 like this. We say DAI token equals new Web3 ETH contract. We pass in the ABI, and then we pass in the address. And again, all that comes from this thing right here. So like here's the ABI, and then the address comes from this networks tab here. Here's the address inside of here. Boom, address, okay. ABI here, address here, okay. And then we create the Web3 version like this. So I'll show you the Web3 documentation for that. Contract, okay. So basically you just say new Web3 ETH contract. You pass in the ABI, which is just the description of how the contract works. It's the functions and everything, and then paste in the address. So ABI address. And then we update the state right here. So we just say the Dapp token gets stored here, or the DAI token gets stored here, okay? And then what we do is actually fetch the balance, because we want to fill that in as well. So the balance gets stored here. And we just say await DAI token methods. So this works a little bit differently from the Truffle contract that we did in the test, but we call the balance of function by saying DAI token methods balance of, and then pass in the account, because that's the current address that's using it. So this account here. And then we say call. So let me show you how that works. So go back to Web3 documentation, my methods call. So this is how you call any smart contract method where you read information from the smart contract with Web3. You say contract methods. That's all the functions on it. You give it the method name. So in this case, it's just balance of, okay? Then we give it one argument, which is the account. And then you can't just do this, because that'll just return the function itself. You actually have to say call whenever you're reading information, okay? So you do .call, and then we assign that to a variable, and then we say this .set state, DAI token balance is the DAI token balance to string. All right, so we'll save that, refresh the app, and it works. Boom. We can even console log the balance here. You can say console.log balance DAI token balance. It should be 100. Yeah, boom, there we go. So it's 100, but it's in way, remember, because so it's got a bunch of zeros, extra zeros after it, but we'll format that later. All right, so now I'm going to remove that console logging statement, and we're going to do the exact same thing, but for the Dapp token. So that's the DAI token. Remember, there's two cryptocurrencies involved, the DAI token and the Dapp token. This is the one that we deposit, and the Dapp token is the one we earn. So I'll just, copy and paste that, and then we'll change the variable values like this. So we'll do Dapp token instead. All right, boom. So Dapp token, all right. And then we change the Dapp token ABI, Dapp token address, set state, fetch the balance, okay? So again, if you get stuck, you can look at the final code solution in the description down below. But yeah, that's how that works. And then I'll just show you, like if we change networks, oops, we got to import the Dapp token as well. So let me do that. Sorry about that. So Dapp token, DAI token, Dapp token. And then we also want to go ahead and import the token farm, because we're going to do that next. So token farm. Okay. And then let me just show you like how the network selector works. So if we go to like the Ethereum mainnet, it won't exist. So we can do like mainnet, refresh the page, and then boom. So DAI token contract not deployed to the network. So that code is working. So if it can't find it, then it'll tell you, hey, like this contract doesn't exist. All right. But if we go back to Ganache, then it'll work. Boom, it works. Okay. So I'm also going to remove this console logging statement here. Done. That was just the network ID, so we don't need to log that to the console anymore. So last, we're going to load the Dapp token farm. All right. And paste this in here. So again, you can find this in the code solution below, but I'll just walk you through it. We do the exact same thing we did with the other tokens. We create the contract, we store it to the state, and then we fetch the staking balance, okay? So this works a lot like balance of, but we just say staking balance for this account, and we call it, and then we save that to the state as well. So we have the DAI token balance, the Dapp token balance, and then the staking balance. So the last thing I'm going to do is update this loading state. So basically we're keeping track of this variable because like while the app's loading, we don't want to show the content on the page. We're going to create a loader here in a minute, but this will allow us to like keep track of that loading. So once all this is finished, we'll basically just say this.setState loading is false. Okay, so by default, it's true whenever we load the app, but once all the data is fetched from the blockchain, we'll say the loading is now done. So loading is false. Okay. All right, there we go. So now we have all the blockchain data in the application. So that's a lot. I know there's, especially if you're brand new, that might be really scary. If you want to go back and review any of this part of the video, that's totally fine. And if you get stuck, you can look at any of the code from the code solution. You could just copy and paste this entire function inside your project, and that should get you unstuck. All right, so that's it for this section. We've loaded all the data from the blockchain into the app. We've connected the app to the blockchain. We've, added our accounts to MetaMask. So this is really just the front end setup. It's a lot of work to get started, but that's it for this section. And in the next one, what we're going to do is actually just fill in the rest of the app, get it to work, allow people to stake tokens into the app, and then start earning them. So I'll catch you in the next one. All right, so now let's finish off the project. We're going to just fill in all this content on the page, add all the functionality to actually interact with the blockchain. In the last section, we loaded up all the data from the blockchain. We've got pretty much everything we need inside the app now, and all we need to do is just wire it up, and we're ready to go, okay? So first, what I want to do is create a new component, all right? We'll call this content, or let's call it main, okay? So a new file, we'll call it main.js. So, we got this app.js component and we have a nav bar, but now we want to add the main component. So basically the reason we're going to do this is because we want to make this loader work. So like when the app is loading, we don't want to show the content yet, but once it's loaded, we want to show it on the page because basically we need the right information in there in order to make it work, okay? So what we'll do is just copy this whole thing, and then we'll do this main component. We'll clear out all this stuff. Well, first of all, we'll just rename this. We'll call it main, all right? And then we'll take away all this. We'll just say React, and then main. Take away all these functions. All we need is a render function right now. So we'll take this away. And then we'll also call it main down here. So instead of export app, we'll export main. And then we'll take away all the functions, all this content. And then we'll just call it, move this hello world into here. Okay. All right, so now what we'll do is just render the main component so that we see it, main, okay? And then we'll refresh the page and it should look the exact same. So it didn't quite work because we didn't import main. So we created main, but we didn't import it. So we'll do that at the top of the file like this. Basically, we'll just say this above right below nav bar, we'll say import main from ./main. That just means the current directory, and then find the file called main. All right, so let's try it again, and boom, there we go. Hello world, still works. Awesome. So here, I'll show you why we did that. So basically what we're gonna do is say, if the app is loading, then we don't wanna show the content of main. And if it is loading, we don't want to show it. And once it's finished loading, we'll render it out of the page. So we'll do that like this. We'll say let content, and then we'll say, if this state loading, okay, we'll show a loader. We'll say content equals this. All right. So we'll say, loader. And if it's not, we'll say content equals, main, all right? and then we'll render the content like this. We'll use curly braces. This just allows us to evaluate JavaScript inside this HTML code. So we'll say content. That's just the variable that we assigned here. So the content's going to be HTML or a component, depends. So we'll just render the page. And boom, there you go. So you can see the loader, and then it flashes. And then so like whenever the blockchain data is finished loading, it'll actually render it onto the page. So like if we go in and take this away, it'll just stay loading forever. All right. But we can see that whenever the data is actually finished loading from the blockchain, it shows on the page. So boom, awesome. That works. So now the main component's wired up, but now we want to pass a bunch of content as props down to the main component, okay? So we want to say like the DAI token balance, the Dapp token balance, et cetera, et cetera. So basically all of this stuff needs to go down to the main component. So I'll just paste that in like this. Basically, say this, boom. So we put this on some new lines. We say DAI token balance equals DAI token balance from state, Dapp token balance, staking balance, stake token, well, don't do this yet. All right. And then that will pass it down to the page. All right. So you can find this down the code solution for the final project if you want to, or you can just pause the video and do exactly what I've done here. So let's go refresh the page, and then boom, there we go. Awesome. So now what I want to do is create some UI on the page for the project. So inside of the main component, we want to do a couple things. First of all, we want to add some stuff to our div like this, add some classes. All right. We want to call it content. All right. Take out this hello world. And we want to use class name. So you have to use class name in React instead of class because it conflicts with the React naming convention. So MT3 is just some nice padding, or margin, I should say, from the top. So what I want to do is actually create a table. So we can create a table to add the balance at the top like this, boom. So you can find this in the code solution if you want to, but I'll explain it, how it works. So basically, it just creates an HTML table with a header, okay, for the stake, and we tell it the staking balance and then the reward balance. So we take this .props.staking balance, which was passed in from here, okay, staking balance, and then also the Dapp token balance, and then we convert them from Way to the Ether value, which is just the actual token value. And then we show the balance on the page like this, mDAI and Dapp. So let's save that, go back to the page, and boom, there we go. Awesome, we got some content on the page. So we can see the staking balance. It's currently 0, which is fine because they haven't used the app yet. And then they also haven't, been rewarded any Dapp tokens either because they haven't, we haven't issued any, and they also haven't staked any tokens yet. But now you can see the balances listed on the page. All right, so we're getting somewhere. All right, so next, what we want to do is create a card for holding all the content. So we'll create the table, give ourselves some space here, just so that we can, see everything. And we're going to paste in this. And then like this. Okay. So this will be, we can put hello world inside here if you want to. Okay. So now we've created a card. All right. So this is where a lot of the content's going to go. So we'll put the form inside of here to allow them to stake their tokens. So I'll go ahead and do that like this. Basically, we're going to create a form. Okay. So here you go. So inside the code, do it like this. Basically, we'll create a form inside this card body. So take out this hello world. Put this form like this, boom. All right. So this is not the final form in the code solution, but what you do here is just create a form, and then I'll show you what it looks like on the page. All right. So DAI is not defined. That's okay. We got to import that in the project as well. So if we go back to the main.js, we import the DAI logo. So just below React, do DAI, all right? And there we go. Awesome. So that looks really nice. So here's the form inside of the card body. Basically, we can see the actual DAI balance. So this is actually how many DAI tokens they hold, or mock DAI tokens, so MDAI. And then we have a form that's going to allow them to stake. So it doesn't work yet. If we click it, it doesn't do anything. So we'll wire that up, but I'll just walk you through the code, show you how it works. It's basically, we have this form element with the label for staking tokens, and then we show the balance. So we actually take in the DAI balance. So this .props.DAI token balance, we passed that in here. All right, DAI token balance. All right, we passed it down here. And then we created an input to do that. And then we have a button for submit. All right. So now what we want to do is actually submit the form and save the tokens to the blockchain, allow them to stake them. So the first thing we need to do is use something called a ref. Well, actually, first, let's do it this way. Basically, we'll create an onSubmit handler for the form. So basically, whenever it's submitted, we'll run a function. So we'll say onSubmit. Submit equals this, okay? And then we'll fill it out like this. So onSubmit is basically just a function that gets run whenever the form is submitted. And then we'll create the logic to actually write the transaction to the blockchain. So boom. So we'll say onSubmit. We'll pass in a function. We'll say event prevent default. So basically, this doesn't like submit it basically like doesn't navigate to a new page after submission. Isn't it send a post request on the page? So, but basically what we do is say we let amount, and we get the input value of the tokens, all right, from the form, and then we convert them to the weigh amount, and then we call the stake tokens function, which we haven't defined yet. I'll show you how that works in a second. But so we want to fetch the value of this form here. So if we type in 100, we need to know that value anytime we stake. So it's not working yet, right? So we do that with refs inside React like this. So just below text and the input, I'm going to fill this in. So basically we say ref input is equal to this. All right, this dot input equals input. So we can fetch that here. So we assign input here, and then amount becomes this dot input dot value. So we couldn't say this dot input dot value unless we added this ref here. Okay, so that's the amount. And then we convert the amount to weigh. All right, so basically we go from, if we do 100 tokens, instead of saying, 100 here, it's going to say 100 followed by 18 decimal places, because that's how the weight works. And then finally, we actually need to call the stake tokens function, which we have not defined yet. So I'm going to define it here in the top level component. So the app.js file. I'm going to create a new stake tokens function like this. So I'm just going to copy and paste this so you can see how it works, and I'll explain it. So basically, we'll do it here. We'll say stake tokens, all right? So this is just a function that we define. We pass in the amount, and then we set the state to loading as true, but then we actually interact with the blockchain, and it's a two-step process, remember? So basically, we approve the tokens first so that they can be spent, all right, and then the amount. And then we send the transaction from the current account, and whenever it's finished, we stake the tokens, so approve, then stake. All right, we pass in the account, and whenever that's finished, we set the state back to loading is false. Okay, so now we can pass that function down here and say, we just pass it in like this. All right, stake tokens. Okay, and then that should work. So let's give it a try, see if we missed anything. So we'll try to stake 100 tokens. Click stake, and then you see a MetaMask confirmation pop up. So it's going to be two transactions. The first one is to approve the tokens for spending. All right, so that worked. And the second one is going to be actually staking the tokens. And let's see if it worked. Yep. All right, so let's refresh the page. This might take a second. You might have to refresh a couple times, but boom, there you go. We see the staking balance has increased by 100, and the balance is now 0. So it was, 100 here. We staked it. Now they're in the app. So let's implement the logic for unstaking, all right, before we do rewards. So we can go back to the app.js file and do unstake tokens, just like we did staking. So say unstake tokens. All right, we can give it an amount. And then basically it'll just call the unstake function from the smart contract, just like the stake function that we wrote earlier. We did it with tests. So inside the token farm, or sorry, inside the main component, we'll create another button below the submit button. All right. So we'll do it like this. Submit. So just after the form, we'll create a new button that's unstakes the tokens. So it'll just be a button tag. It'll have an on-click handler, okay? So whenever it's clicked, we'll prevent the default, and we'll just call the unstake function, okay? And then we'll pass it in here. So just below stake tokens, we also need to add unstake tokens. All right, so we'll do that like this. Basically just below here, we'll say unstake tokens. All right. And then we'll go back to the page. All right, there we go. There's our unstake button. So let's give it a try, see if it allows us to take them out of the app. Confirm. And then boom, there we go. So we took the tokens out of the app, and then now they're back in our wallet. Awesome. So that's pretty much all of the logic of the application wired up. All right, so what we want to do now is actually show how to earn tokens with interest, okay, for using the app. So the investor, that's who we're acting as here, has DAI. They want to use the app. So let's stake tokens. We'll say, 100 tokens. Stake it. It'll approve them. All right, then it'll stake them. And then we'll refresh the page. And then now the balance has changed. And now the owner, all right, can run the script to distribute the tokens. So say Truffle exec scripts, what was it called? Issue tokens. All right, so it worked. Let's go back to the app, refresh the page. We might have to refresh a couple times because sometimes it takes a while for Ganache to update. Boom, there we go. 100 Dapp. Awesome. So we have successfully, participated in liquidity mining, in yield farming. So it works. Awesome. So the whole idea here is that, the owner of the application could, set this up on a regular interval. It could be every day, it could be every hour, it could be every block, every week, every year, et cetera, et cetera. But we can run it again, and, the investor will have more tokens. All right. Boom. There we go. 200 Dapp. And now they can unstake, claim their tokens, click confirm. And then there we go. They don't have any tokens in the app anymore. And now they have their tokens back, but they still have 200 Dapp tokens that they can go take them and sell them on Uniswap, do whatever. They've farmed the tokens and they're theirs. Okay. So that is it, guys. So what you could do if you wanted to, continue playing with this app is you could basically change the behavior. You could say they earn less tokens for staking. Maybe they earn, a fraction of the amount of tokens that they stake, maybe more, et cetera, et cetera. But that gives you insight into how a lot of this yield farming stuff works. And of course you could, create the smart contract to be more advanced where, once they stake the tokens, they're used for lending or something like that. But this gives you an idea of how the initial token distribution method works for something like liquidity mining. Okay. See how it works. You've written it in Solidity and you've created a front-end application that does all this stuff. So congratulations, you've come a really long way in this tutorial. So those are some ideas on what you can do. But that's an insight into this hot new, DeFi, yield farming, liquidity mining trend. And congratulations, you've done all this hard work. So where do you go from here? Well, first and foremost, if you like this video, smash the like button down below, subscribe to the channel. of course. And, you know, if you want to take the next step, I highly recommend heading over to dappuniversity.com/bootcamp. You can just click the link here in the top left-hand portion of your app. And I can show you how to master blockchain step-by-step from start to finish. You know, build a real-world advanced blockchain app, DeFi app, a cryptocurrency exchange powered by smart contracts on the blockchain. It's a real-world project. You could just click a button and deploy it and have a real world functioning Dapp on the Ethereum mainnet. And I'll show you how to do that. So again, I hope you like this video. And until next time, thanks for watching Dapp University.